Hi everyone, I welcome all of you to video solutions of NTSE Stage 2 SAT paper. So it's been conducted on 16 June 2019. Here I am going to discuss the mathematics part. In this SAT paper, the mathematics part is from question number 41 to question number 60. So let us firstly take question number 41. Here it states if m is equal to n square minus n, where n is an integer, then m square minus 2m is divisible by which of these four options? So in this question, we are talking about m equal to n square minus n. So in this case, if you consider this value of m, it is provided as n square minus n. You can simplify it as n into n minus 1. Now here you have to show and figure out by which number m square minus 2m will be divisible. So I write here m square minus 2m. And I try to substitute here the value of m. So I obtain in this case that it is m into m minus 2. Where on substituting the value of m, I clearly get here n into n minus 1 into n square minus n minus 2. You can easily factorize this quadratic polynomial, and on factorizing it you get here n into n minus 1 into n minus 2 into n plus 1. So if I rearrange this value of m square minus 2m, it is equal to n minus 2 into n minus 1 into n plus 1. And when you observe this, this is clear product of four consecutive integers, and product of four consecutive integers is always divisible by 24. So here I could definitely write here that product of four consecutive integers is always divisible by 24. Taking this case into consideration, I can clearly get here the answer for this question, that m square minus 2m is divisible by 24. You can clearly find that in option number 2. So the correct answer for this question is option 2. I hope it is clear to you. Now let's take up question number 42. Here this question states the value of square root of 97 into 98 into 99 into 100 plus 1 is equal to out of these four options. So here in this case, as you need to obtain value of this quantity, what you can do, you can multiply and simplify it to get the required value, or else we can use the approach of algebra, where I am going to solve it for you using algebra. Here, if I consider this given quantity, that is 97 into 98 into 99 into 100 plus 1, I am taking here that 97 is equal to x. So let 97 is equal to x. If I take this criteria, then this given quantity simplifies to x into x plus 1 into x plus 2 into x plus 3 plus 1 and square root of this whole. So here when I take the product of x and x plus 3, that gives me x square plus 3x. And when I take the product of x plus 1 and x plus 2, it gives me here x square plus 3x plus 2 plus 1 I have here. Next, here if you can observe, I have x square plus 3x. If I multiply this further, it will become biquadratic. So let's take here that x square plus 3x is equal to y for easier calculation. So now taking that into consideration here, this becomes y into y plus 2 plus 1, and when you simplify this, you get here y square plus 2y plus 1 and square root of that. And you can clearly observe y square plus 2y plus 1 represent y plus 1 whole square. So this is equal to square root of y plus 1 whole square. So this root will get eliminated and I will obtain here y plus 1. Where y is x square plus 3x, let's substitute it back. So as y is x square plus 3x, so I get here x square plus 3x plus 1, and earlier x was 97. So let's put it back here. as x is 97, substituting it here, I get here 97 square plus 3 times 97 plus 1. And when you simplify this, you will getting here the required answer as 9701. So here we get the required answer for this question as 9701. And out of the 4 options given, you can now clearly identify the correct answer, which is here in option number 4. And you can definitely mark the answer as option 4. I hope this question is clear to you. Now let's discuss our next question. Now let's discuss question number 43. It states here that let p of x be a polynomial of degree 3, and here it's given that p of n is equal to 1 upon n for n equal to 1, 2, 3 and 4. Then the value of p of 5 is, out of these 4 options, you need to obtain the correct answer. So here let's try to figure out what is the value of p of 5. So you can observe here in this case it has been provided that p of n is equal to 1 upon n for n equal to 1, 2, 3 and 4, and it's been already given to you that p of x is a polynomial of degree 3. That means it is a cubic polynomial. So here if I simplify this, n into p of n equal to 1, here n into p of n becomes a biquadratic polynomial that has 4 zeros. So here I could definitely get that n into p of n minus 1 equal to 0 will have 4 zeros. For n equal to 1, 2, 3 and 4, this is valid. So its zeros will be 1, 2, 3 and 4. So I can definitely consider that n of Pn minus 1 is equal to, let's suppose, k, the constant into, I have n minus 1 into n minus 2 into n minus 3 into n minus 4. Because this is a biquadratic polynomial this time. Now, as I want here the value of p of 5, let's substitute here n as 0 and see what we obtain as the value of k. So, if I let n is equal to 0, then in that case, I get that minus 1 is equal to k into minus 1 into minus 2 into minus 3 into minus 4. That gives me the value of k equal to minus 1 upon 24. So, as I have obtained the value of k, so let's write this equation substituting the value of k. I can definitely write here that n times p of n minus 1 is equal to minus 1 upon 24 into n minus 1 into n minus 2 into n minus 3 into n minus 4. So, this is obtained as we need here the value of p of 5. Let's substitute here n as 5. If I consider here n as 5, let's see what we get in this case. I will be getting here 5 into p of 5 minus 1. This is equal to minus 1 upon 24. When you put here n as 5, you get here 4 into 3 into 2 into 1, that is also 24. So, this simplifies. Then minus 1 is transposed to the other side, resulting 0. So, I get here the value of p of 5 equal to 0. That means, according to the given condition of the question, the correct answer will be 0 as the value of p of 5. I hope this question is clear to you. Let's get back to the options provided to us. Here, out of these 4 options, now you can clearly say that the value of p of 5 is in option number 1, that is 0. So, you can easily mark your answer as 1. I hope it is clear to you. Let's take up now question number 44. Here I have question number 44. It states that if alpha and beta are the roots of the equation 3x square minus 5x plus 3 equal to 0, then the quadratic equation whose roots are alpha square beta and beta square alpha is out of these 4 options. So, according to this given equation, that is 3x square minus 5x plus 3, I can get a clear idea that its roots are alpha and beta. So, the sum of roots alpha plus beta will be definitely equal to minus b by a, that is 5 upon 3 in this case, and alpha into beta will be c by a, that is 3 upon 3 equal to 1 in this case. So, for obtaining the quadratic equation, I need the sum of roots and product of the roots. So, in this case, if I want to get the sum of roots, that is alpha square beta plus beta square alpha, this will be given by alpha beta into alpha plus beta. So alpha beta is 1, alpha plus beta is 5 by 3. So the sum of roots is clearly equal to 5 by 3. Next, coming to the product of roots. Here you can definitely state that product of roots will be alpha square beta into beta square alpha. That is alpha beta cube. So this is cube of 1 equal to 1. So now you know what is the sum of the roots of the new quadratic equation and what is the product of the roots. Taking that into consideration, you can easily get your quadratic equation, which will be given by x square minus sx plus p equal to 0. Substituting here the value of s equal to 5 by 3 and p as 1, you will be getting in this case x square minus 5 upon 3x plus 1 equal to 0. When you will simplify this on taking LCM, you will get here the quadratic equation 3x square minus 5x plus 3 equal to 0. And out of these four options, the correct answer will be 3x square minus 5x plus 3 equal to 0. So I could clearly state that in this question number 44, the answer is option number 1, that is 3x square minus 5x plus 3 equal to 0. I can clearly mark here the answer as option 1. I hope it is clear. Let's take up our next question.